Okay, we have f of x equals x squared plus 6x minus 7, and we want to find the inverse. Well, we know the trick for the inverse. We call it y, so y equals f inverse. Do f of both sides, so f of y is f inverse of x, and f inverse cancel out. Now, if I sub y into there, look, so I get y squared plus 6y minus 7 equals x. And I want to rearrange to get x equals, I've got two y's, that's y equals, sorry, so there's two y's, that's an issue. So instead, I need to get just one y. So think about what tricks you can do with quadratics, and it shouldn't take you long to think of completing the square. So y plus 3 squared minus 9 minus 7 is x. So y plus 3 squared minus 16 is x, plus 16 to both sides, square root both sides, and take away 3 from both sides. There you go, so the inverse is minus 3 plus root x plus 16. Okay, second one. Use differentiation to determine whether or not y equals sine x squared plus 1 is concave or convex when x is 2. So that means we need the second derivative. So dy by dx is, well, goes to cos. Sine goes to cos, and I have to times it by the derivative, so I get 2x. Now to differentiate that, look, I've got a product, so I'm going to have to use a product rule. So u equals 2x, v equals cos x squared plus 1, u dash is 2, v dash is cos goes to minus sine. And I have to times by 2x. So I get minus 2x sine x squared plus 1. So do the padding. So second derivative is, well, 2 times cos, so 2 cos x squared plus 1. And then 2x times minus 2x sine x squared plus 1 gives me 4x squared sine x squared plus 1. And I'm going to plus and minus, so I'll just mix a minus. Now, what I'm going to do is I'm going to sub in x as 1. I don't want an exact answer, I don't need an exact answer, so to sub 1 into that, make sure I'm in radians, and I should get, when I do that, oh sorry, x is 2, not 1, and when I do that, I should get 15.91, which is positive, and if the second derivative is positive, it's convex. Yeah, I didn't need an exact answer for that because I just wanted to check if it's positive or negative. Okay, third one, we want to solve the equation. The modulus of 2x minus 1 is less than or equal to x plus 3. So the first thing we do is we need to get the critical values. So I need to find out when they're equal. So I sketch the graph, we get modulus of 2x minus 1, something like that, and x plus 3, something like that. So I get two critical values. One on the positive branch, so that's where y equals 2x minus 1, and one here where y equals minus 2x minus 1. So if I solve that one first, I get 2x minus 1 equals x plus 3. We'll take away x from both sides and add 1 to both sides. So x is 4, is this one. And this one here, so minus 2x minus 1 equals x plus 3. So expand the bracket, so minus 2x plus 1 equals x plus 3. So plus 2x to both sides, and take away 3 from both sides, and divide both sides by 3, so minus 2/3. So this one should have been over there, x is minus 2/3. And I want, when is the modulus less than the straight line? So it's in between these 2 points where the modulus is less than the line. So minus 2/3, less than or equal to x, less than or equal to 4. Okay, fourth one, we have a circle, x minus 3 squared plus y plus 1 squared equals 37. So the center is 3 minus 1, so somewhere here, there's my circle. and I want the tangent to the 0.45, so somewhere there. So there's my tangent. So in order to get the equation of the tangent, I need the gradient, and I know that the gradient is perpendicular to the radius. So I need to get the gradient of the radius. So that goes from the point 3 minus 1 to 4, 5. So I do my change in y over change in x. So 5 minus 1 divided by 4 minus 3 gives me 6 over 1. So the gradient of the radius is 6. So therefore, the gradient of tangent is perpendicular, so it's minus 1 over 6. Yeah, if I knew how to differentiate this, I could differentiate it and I wouldn't have to do the negative reciprocal, but since I can't differentiate this yet, I have to use the trick of getting the radius first. So I can use y minus y1, and the point on the curve is 4, 5. So y minus 5 equals minus 1 over 6, x minus 4. Time both sides by 6, so 6y minus 30. And expand this side by minus 1, so minus x plus 4. Take x to that side, so plus x to both sides, so x plus 6y, and take away 4 from both sides, so minus 34 is 0. Or you could rearrange to get y equals, I don't mind. And last one, partial fractions. So we have 4x squared plus 21x minus 8 equals x plus 3, 2x minus 1. So first thing we need to check is it proper or improper? Well, I've got a x squared in the top, and if I expand the bottom, I have an x squared in the bottom. So it's improper, and the powers are the same. So x squared divided by x squared will give me just a number. So I have a number plus something over x plus 3 plus something over 2x minus 1. Now, remember, to get the number, if I was dividing it, I would do 4x squared divided by 2x squared. So a would end up being 2. Actually, I'm going to write that a should be 2. And I'm going to try and we'll show you that would work. So times both sides by x plus 3, 2x minus 1. So I get my identity, 4x squared plus 21x minus 8 equals a lots of x plus 3, 2x minus 1, plus b lots of 2x minus 1, plus c lots of x plus 3. So sub in my magic numbers. So when x is minus 3, this side becomes 4 times 9, take away 63, take away 8. I get minus 35. This disappears, so I've just got this. So that gives me minus 6, minus 1, so minus 7b. So therefore, b equals 5. So then x equals a half. So 4 times quarter, so that's 1 plus 21 over 2, take away 8. So I've got 7 over 2 on this side. That'll disappear in this one. So I put a half into there. I get half at 3 gives me 7 over 2, so 7 over 2c, therefore c equals 1. And to get a, I would sub a random number in, but I told you it's going to be 2, so look, 4x squared divided by 2x squared gives me 2. But just to prove it, if I put 0 in, I get minus 8 equals minus 3a minus b plus 3c. Now, b is 5, and c is 1, so plus 3, so that gives me minus 2, plus plus 2 to both sides, I get minus 6 equals minus 3a, so therefore a equals 2, like we said. So we get 2, b was 5, and c was 1, so we get that.